The idea of creating an artificial sun has long been a staple of science fiction, but what if humans were actually able to make this a reality? The concept involves replicating the fusion reactions that occur in the sun, but on a much smaller scale and controlled environment, in order to produce a source of sustainable energy. This would be a major breakthrough in energy production, potentially solving the world's energy problems and providing unlimited power for future generations. This is Fantasy World. We try to imagine everything about your fantasy. An artificial sun would not only provide a virtually limitless source of clean energy, but it would also reduce the world's dependence on finite energy sources. The burning of fossil fuels, such as coal, oil, and gas, is the primary source of carbon emissions, which are contributing to climate change and global warming. The use of nuclear reactions also presents risks, including the potential for accidents in the long-term storage of radioactive waste. With an artificial sun, these risks would be eliminated as the energy source would be clean and renewable. Another major benefit of an artificial sun is its stability. Unlike other energy sources, such as wind and solar, which are dependent on weather conditions and subject to fluctuations, an artificial sun would provide a constant source of energy. This stability would help to ensure that energy needs are met consistently, even in areas with less predictable weather patterns. It would also reduce the need for energy storage solutions, such as batteries, which are currently required to store excess energy from wind and solar sources. In addition to providing clean and stable energy, an artificial sun could also stimulate economic growth and create new jobs. The development and deployment of an artificial sun would require significant investment and would generate employment opportunities in research, engineering, and construction. The resulting energy source could also be used to support new industries and technological advancements, further driving economic growth. Finally, the creation of an artificial sun would demonstrate humanity's technological prowess and ability to tackle complex global challenges. It would serve as a symbol of our ingenuity and a testament to our commitment to creating a better future for generations to come. With the world facing significant environmental and energy challenges, an artificial sun could be seen as a beacon of hope and a step towards a more sustainable future. One of the major challenges of creating an artificial sun is replicating the conditions of the sun. The sun produces its energy through fusion reactions, which occur at extremely high temperatures and pressures. To replicate this, scientists would need to create a controlled environment in which the fuel, typically hydrogen, would be heated to millions of degrees Celsius and subjected to immense pressure. This would cause the hydrogen atoms to fuse together, releasing a tremendous amount of energy in the process. In order to make an artificial sun a reality, researchers must first overcome the challenge of creating a material that can withstand the intense heat and pressure of the fusion reactions. The temperatures required for fusion to occur are extremely high, reaching hundreds of millions of degrees Celsius. This requires materials that can withstand not only these temperatures but also the intense pressure of the plasma in which the fusion reactions take place. The development of such a material is a significant challenge, as it must be able to withstand the conditions for a sustained period in order to make the fusion reaction viable. Currently, the materials that have been developed for use in fusion reactors are unable to withstand these conditions for long enough, meaning that the reaction would quickly break down and the energy source would be lost. This is a major obstacle that must be overcome if an artificial sun is to become a reality. Another challenge in creating an artificial sun is the issue of containment. The fusion reactions produce high-energy particles that must be contained within the reactor to prevent them from escaping and causing damage to the surrounding environment. This requires the development of a containment system that is able to withstand the intense heat and pressure of the reactions, as well as the high-energy particles produced. In addition to these technical challenges, the creation of an artificial sun also faces significant financial hurdles. The development and deployment of such a technology would require significant investment, as well as ongoing research and development to ensure its viability and sustainability. This may make it difficult to secure funding for the project, especially in light of competing demands for investment in other areas of energy production and technology. Despite these challenges, researchers and scientists are continuing to work towards the development of an artificial sun. The potential benefits of such a technology make it an area of research that is well worth pursuing, and with advancements in materials science and technology, it may only be a matter of time before an artificial sun becomes a reality. In recent years, there have been significant advancements in the field of fusion energy research. Major international collaborations, such as the ITER project, are working to develop the technology needed to create a sustainable source of fusion energy. The ITER project, for example, is building a large-scale fusion experiment in France, which aims to demonstrate the feasibility of fusion as a source of energy. If humans were successful in creating an artificial sun, the impact would be profound. It would provide a sustainable source of energy for the future, helping to ensure that the world's energy needs are met without sacrificing the planet's health. It would also greatly reduce the world's dependence on finite energy sources, such as oil, gas and coal, and could lead to a more sustainable and equitable energy system. Additionally, there is also the potential for an artificial sun to be weaponized. With its tremendous energy output, it could be used as a powerful tool of destruction in the hands of hostile nations or organizations. The development of this technology would therefore require the creation of stringent international regulations and safeguards to prevent its misuse and ensure that it is used only for peaceful purposes. Another ethical consideration is the impact that an artificial sun could have on the natural environment. The deployment of this technology could have significant and lasting impacts on wildlife, ecosystems, and the balance of the planet's climate and weather patterns. It is therefore important that any development of this technology takes into account the potential environmental consequences and takes steps to minimize any adverse impacts. Finally, it is important to consider the impact that an artificial sun could have on human society and culture. The widespread use of this new energy source could result in significant changes to the way we live, work, and interact with each other. It could also result in the creation of new industries, jobs, and technologies that could transform our world in ways that we cannot yet predict. In conclusion, the idea of creating an artificial sun is both exciting and daunting. The potential benefits of such a project are vast, providing a source of clean and sustainable energy for future generations. However, significant technological and ethical challenges must be overcome before this dream becomes a reality. Nevertheless, the potential benefits of an artificial sun make it an area of research that is worth pursuing, and one that could have a profound impact on the future of energy and our planet.